Hello, my name is Robbie Schwartz, and welcome to this presentation on the mandatory requirements of the IECC that are also part of the Boulder County's BuildSmart code. These requirements go beyond the HERS Energy Rating Index or building programmatic compliance documentation that are needed to obtain the building permit and/or the certificate of occupancy. Table N1106.2.1 lays out the mandatory section of the BuildSmart code that are required when using the HERS Energy Rating Index compliance pathway. The table's structure has been borrowed and amended from the 2021 IECC Mandatory Requirements Table in the R405 Simulated Building Performance and R406 Energy Rating Index compliance sections. The table is designed to centrally place all the requirements that are embedded within the ICC and now BuildSmart code to better clarify that in addition to determining how the home will achieve compliance with the required HERS Energy Rating Index score, the home must also comply with these other requirements that are embedded within the code. The table divides these mandatory requirements into the following four sections: N1101 General Requirements, N1102 Requirements that have to do with the installation and performance of the building thermal envelope, N1103 Requirements regarding mechanical systems and service hot water systems, and finally N1104 Electrical Power and Lighting Requirements. I'm going to go over these requirements in some detail, but I will not be touching on every requirement in each section, so please take some time to review the requirements table N1106.2.1 and especially those sections that I'm not going to speak to specifically in this presentation. Let's start with the general mandatory requirements that come out of the N1101 section of code. The general requirements listed on the slide are largely embedded within what would be Chapter 1 of the 2021 ICC. They are now in Section N1101 of the BuildSmart code. Since many people do not read these sections of code, I am going to go over them in some detail to ensure that they are understood. Starting with N1101.5, Information on Construction Documents. Those highlighted requirements are ones that are often left off of the construction documents, but are crucial pieces of information that the plans examiner needs to understand regarding your proposed building permit. So beyond including the R values and U factors for all your building assemblies, as well as the HVAC design information, which is more fully required in the N1103 Mechanical Systems section of the table, you'll need to provide air sealing details, details of additional electric infrastructure, including branch circuit, conduit, or pre-wiring, and panel capacity in compliance with the provisions of this code. Location of pathways for routing of raceways or cable from the solar ready zone to the electric service panel. Location and design of the EV ready spaces are some of those things that should be included on the construction documents. These are two examples of the type of air sealing details that are required to be included on the construction documents. We will come back to this requirement in much more detail when we talk about the building thermal envelope requirements in section N1102. But these details show the placement of a supplemental air barrier that's required. First, behind a tub that is located on an exterior insulated wall, and second, to separate a drop ceiling from the ventilated attic. In both cases, the installation of the supplemental air barrier brings a component of the assembly inside the building thermal envelope. Here, the tub and the drop ceiling are no longer in limbo. They are clearly within the building thermal envelope. I want to let you know that example details that are required on your construction documents, like those that I just showed, are available at no cost on the Building Energy Code Toolkit section of the Colorado Energy Office website. They are a little difficult to find, so here are direct links to the details and a guide that describes each detail. Remember that when a section is called out in the mandatory requirements table, that all subsections are also requirements. In this case, the design team is required to depict the building thermal envelope on the construction documents. This depiction is often called the red line test and is generally done on one or more sectional drawings. Boulder County, however, requires that this depiction be done on a sectional drawing and on a plan view within the building documents. There is no requirement to depict the building thermal envelope as shown. This depiction, however, shows the continuity of the thermal control layer as well as the air control layers as the Energy Code looks at it. The building thermal envelope is defined by the BuildSmart Energy Code as an assembly of things that come together to create a clear boundary condition between conditioned and exempt unconditioned space. The boundary condition is crucial to define in order to understand the requirements of continuity of air barriers, insulation, weather-resistant barriers, and more, as well as for HVAC design conditions. Section N1106.2.1 Interior Design Conditions states that the interior design temperature used for heating and cooling load calculations shall be a maximum of 72 degrees for heating and a minimum of 75 degrees for cooling. See Table R301.2 and Section N1101.9.1 Exterior design conditions state that the exterior design conditions shall be based on climate data for locations, since Boulder County is a jurisdiction that spans a large elevation range from the plains as well as up into the mountains. The thermal side of the building thermal envelope equation is required to be in continuous alignment with the air barrier. The air barrier is a defined term and is defined as one or more materials joined together in a continuous manner to restrict or prevent the passage of air through the building thermal envelope and its assemblies. And the code also defines a continuous air barrier. Therefore, the building thermal envelope is the continuous alignment of the thermal and air control layers in the house all the way around the house, the six sides of the cube, so to speak. The red line test helps to depict where special attention to air sealing details is needed. The circles highlight areas where assemblies come together, like at the roof wall intersection or the foundation wall intersection, where the majority of the air leakage occurs, as we know that little leakage happens within the building cavity itself. The main point of this requirement is to ensure that the design team understands these performance concepts and that the information ultimately gets out into the field to the construction team. So from a code perspective, we are talking about the continuity of the thermal barrier or control layer in alignment with the continuity of the air barrier control layer. It is really a belt and suspenders approach that we're talking about. Basically, you pick your primary air barrier location, either on the exterior or the interior side of the assembly, the sheathing or the drywall, or other material that you might be using to create that air barrier system. Then you need to assess the need for supplemental air barriers, especially when air permeable insulation is installed. Air permeable insulation, like fiberglass or cellulose, for example, when installed in a cavity, must be installed within a six-sided airtight cavity to perform. Regardless of the type of insulation used, continuity of both interior and exterior side, the belts and suspenders, needs to be achieved. When there's not continuity, the code will call for a supplemental air barrier, for example, the air barrier behind a tub on an exterior insulated wall. We'll see more of this when we talk about the section N1102 in the Building Thermal Envelope Requirements section. Here are examples of continuity and lack of continuity, and who is responsible for 90% of the air barrier installation details. Well, it's the framer, when it happens well and when it doesn't happen well. The picture on the left shows what happens when proper sequencing of the installation of materials is not followed. There is no air barrier between the porch and the rim joist between the first and second floor. Once drywall is installed, the problem won't be visible, but outside air will be able to mix with the conditioned air inside the home. In addition, it will be difficult to insulate the rim joist at the porch connection. These problems can lead to hot and cold spots and comfort complaints, as well as a higher energy bill and non-compliance with the code. The picture on the right shows sheathing installed across the entire house and then the porch assembly added on afterwards, the proper installation sequence. This ensures the full continuity of the air barrier across the floor system and the porch connection to the exterior wall. Between the two pictures is an example of a free detail that is on the Colorado Energy Office's website that could be used to be and included on your construction plan set to better ensure proper execution of the building element. So again, the primary air barrier can be on the outside of the house as represented by the smart vapor and air control layer depicted on the left side of the slide, or on the outside of the house as depicted by the blue Siga material or green zip sheathing on the right side of the slide. If you are using fibrous air permeable insulation, then a supplemental air barrier needs to be installed on cavity insulation installations to control the air pockets that create the R value of the insulation. So these code requirements are all about ensuring that we have continuity, continuity, continuity. This section of code is not listed on the mandatory requirements table, but as I mentioned before, it is information that the HVAC design team will need to know when sizing the HVAC system for the house. BuildSmart uses the Common Energy Code interior design temperatures. For the exterior design temperatures, I pulled out an example of the winter and summer exterior design temperatures for the Plains section of Boulder County. You actually would have to go to the IRC section R301 design criteria section of the BuildSmart code to get the exact winter design criteria for your building location. This is also where you would go to get the other design criteria for the wind loads, the frost depth, and other things like that. We typically look for the insulation R value mark on insulation products like fiberglass bats or foam board continuous insulation. We are seeing more and more blown-in-place insulation and continuous insulation products that do not have an R value mark printed on them. Often, with these insulation materials, the R value is solely dependent on the quality of the installation of the material. Therefore, the code is now stating that an insulation certificate, which we often get at the end of the project, be left immediately after the installation of the material to certify the R value of the installed insulation. This puts the onus on the installer to do some level of QA and inspection and to gather the information at the correct stage of construction. Remember, and as we will talk about in more detail later on, that in most cases, a certified energy rater will be the inspector for residential projects for the BuildSmart code, and therefore they will be looking for the insulation certificate that certifies the installed R value on the project. Largely, the energy code and all codes rely on manufactured instructions to ensure that materials, systems, and equipment are installed properly in a house. Again, because few read the first sections of the code, this requirement has been brought forward to the mandatory requirements table. For example, how many have actually read the manufactured instructions for how to install a fiberglass bat? Did you know that there are no manufactured instructions for how to install a 6 mil poly Class 1 vapor retarder? If you were doing it right, you would have to go to the instructions that accompany some of the smart air barrier and vapor retarder membranes that have come onto the market. Also, we need to remember that there are sections of the code that govern the installation of materials that go beyond manufactured instructions. I will point some of those out when we get to the building thermal envelope requirements section. BuildSmart is largely using the HERS Energy Rating Index compliance approach to demonstrate compliance with this code. This means that an energy model is being executed, and the certificate required in this section of code would be printed out by the software program. However, the BuildSmart program and code added some additional things that are required to be on this certificate. So someone, probably an energy rater, will have to develop and print out a certificate to post in the house. The objective of this certificate is that it is a permanent snapshot record of the energy features installed in the house so that when or if an addition or alteration is done, they have an idea of what has been currently installed in the home. BuildSmart lays out the base minimum requirements for a homeowner's manual that must be handed out at the time of the completion of the home. This includes a binder of all equipment and appliance manufactured installation manuals, except for manuals that are required to be affixed to the equipment, the HERS certificate, and off-site renewable energy generation agreements if they are used for that particular project. Demolition of an existing building on a new home building site is not permitted. You are required to deconstruct the building, and the completion of deconstruction as approved on the construction documents and the deconstruction plan must be verified by Boulder County. Also, all construction job site waste must be recycled, including wood, scrap metal, cardboard, and concrete. Go to these sections of the code to get more information regarding these requirements. New and replacement bathroom sink faucets, shower heads, toilets, and urinals must be labeled as meeting EPA Water Sense criteria as spelled out on this slide. Lastly, whenever renewable energy systems are required by the BuildSmart code, the systems must be built on site. There are some exceptions for when a renewable energy contract may be used, but if you intend to use the exception, you will definitely want to go to the section of code to learn more about what is needed to do to qualify for the use of renewable energy contracts. Now we can move on to the N1102 Building Thermal Envelope Mandatory Requirements. The building thermal envelope requirements listed on this slide are largely embedded within what we would call Section R402 of the 2021 IECC and are now in the N1102 section of the BuildSmart code. Unique to the energy code world, BuildSmart is ensuring that the buildings in Boulder County do not use a Class 1 vapor retarder. You will have to go to the 2021 IRC to further understand what that means for the design assembly. But most often it means planning to use continuous exterior insulation and/or a vented rain screen cladding system. Either way, the BuildSmart code has adopted the sound building science that is wrapped into the codes to better ensure that moisture will not get trapped within the assembly because there is drying potential to the inside of the home built into the assembly itself. The specific installation requirements is a section of code that points out installation requirements that go beyond the manufactured instructions. There are 13 assemblies that are discussed in this section of the code that are listed here. I don't have time to cover each of these in depth, so I'm only going to talk to a few of them as an example. Ceilings without attic space. Insulation installation requirement has been amended significantly from the base 2021 IECC that the BuildSmart code is based on. In new construction, the R value of the ceiling insulation will be determined by the energy model that is used to generate the HERS Energy Rating Index score that is required for the project. This section of code states that whatever the R value is, it must be installed over 100% of the attic area. In addition, it must extend over the wall top plate and achieve its uncompressed full R value. This means that if the energy model determines that R38 cellulose insulation is adequate for the project's attic, the house is going to need at least a 13-inch raised heel truss to ensure that the uncompressed R value can be achieved over the wall top plate, including a 1-inch ventilation baffle space as well. This basic insulation installation premise carries over to ceilings without attic spaces, so take a look at this section of code as well. Remember that you will have to choose if the assembly will be vented or not. If it is vented, then the vent space will have to be completely separated from the air permeable insulation or fibrous insulation that is installed within the six-sided assembly. This is another example of a detail that is available on the Colorado Energy Office's website. I wanted to show you an attic scissor truss and a detail on the Colorado Energy Office's website because you not only have to consider insulation over the top plate and heel height, but if you are installing ductwork in the attic, you will need to consider how much height you have to maintain the R value of the insulation with the duct that might be installed near the exterior wall where the heel height is at its lowest point, meaning that the design team may need to increase the heel height in the raised heel truss even more to properly accommodate insulation and ductwork. Knee walls are an assembly that are very common, yet have not been addressed specifically by the Energy Code up until now. Too often, an attic knee wall is framed and insulated completely differently than other insulated exterior walls of the home. This is fine as long as it is addressed in the energy model to achieve the HERS Energy Rating Index score that is required for the project. Otherwise, the attic knee wall must be framed and insulated in the same way as other insulated exterior wall systems. So for the remainder of the assemblies called out in this section of code, you will see that very similar principles are carried forward. The R value of the assembly will be dictated by the energy model, not the prescriptive R value table, since the prescriptive compliance approach is only allowed to be used in certain types of existing home projects. The insulation needs to be installed to maintain the proposed R value throughout the assembly. Each called out assembly adds insulation requirements and installation requirements to the manufactured instructions or to what might be called common installation techniques or practices. Therefore, make sure the design and construction team reads over these installation requirements as field inspection will be holding the project to them. The basement wall section clearly describes the difference between a conditioned and an unconditioned basement, and as depicted on the picture on the slide, the change in the alignment of the building thermal envelope if an unconditioned basement is built. Sunrooms enclosing conditioned space and heated garages used for vehicle storage must meet the insulation requirements of this code, but they are not considered habitable conditioned space. This is really important to recognize as their volume will be excluded when the blower door test is performed on the project. Again, it is recommended that the design and construction team review this section of code as these requirements will be inspected. The majority of the air leakage requirements for your home are handled in the building thermal envelope section of the BuildSmart code. This section talks about how to construct an airtight thermal building envelope, as well as blower door and air leakage testing requirements. The remainder of the air leakage section talks about specific components that need to be used or addressed when constructing the airtight building thermal envelope. I won't be speaking directly to these sections listed on the slide, so please be sure to review them on your own. The BuildSmart code uses the air barrier, air sealing, and insulation installation table to describe how the continuity of the building thermal envelope is constructed to achieve the air leakage requirements that are laid out in the blower door testing section that I will discuss in just a few minutes. These installation requirements are in addition to manufactured instructions to better ensure performance. It should also be understood that about 90% of these details laid out in this section of the code are the responsibility of the framing crew to execute in the field, as the sequencing of the installation of an air barrier first to the bottom quarter of the truss, the attic side of a knee wall, or behind a tub or fireplace on an exterior insulated wall is much easier and faster than trying to install an air barrier after a drop ceiling, a knee wall, a tub, or fireplace has been installed. Boulder County does require that an approved third party, generally an energy rater, verify compliance with the requirements of the air sealing table. I therefore highly recommend that the design and construction team review this section of code thoroughly before designing and construction begins. There are 19 components of the building thermal envelope that are addressed by the air barrier, air sealing, and insulation installation table N1106.2.1.1. They are addressed from an air barrier, air sealing perspective, as well as from an insulation installation perspective. I can't address all the components, but know that the requirements are different than in the base 2021 IECC. In general, the table should be approached by thinking about the specific component, but also how the techniques that are described can be applied to other like assemblies that are not specifically called out. The general section at the top of the table states that the building science principle of continuity and alignment of the air barrier and thermal control layers of the building thermal envelope need to be maintained. In addition, we see that all holes and joints must be sealed that separate conditioned space from unconditioned space. Basically, every hole must be sealed. Looking at the insulation installation column, we see the importance of installing air permeable insulation within an air barrier assembly because the material itself does not stop the flow of air. The above grade wall component in table N1102.4.1.1 is a good example of the differences between the 2021 IECC and the BuildSmart amendments to the air barrier, air sealing, and insulation installation table. On the air barrier, air sealing side of the equation, in addition to the rim joist sealing requirements, the sill plate must be sealed to the foundation. This is in addition to any sill seal that might be installed below the bottom plate to the foundation, because sill seal is actually a capillary break, not an air sealing material. The sealing of drywall to the top plate is explained much better than in the 2021 IECC, and there is the additional requirement to seal the bottom plate to the subfloor. On the insulation side, BuildSmart addresses alignment of the thermal and air control layers and enclosing air permeable insulation on 6 sides of the cavity that it's installed in. You'll want to look at footnote B as it's still in effect, showing where enclosure of air permeable insulation is not required. Attic knee walls are above grade walls that are discussed more specifically in this table and also talk about the requirement of installing an air barrier or sheathing on the unconditioned side of the assembly. In addition, BuildSmart specifically calls out insulated corners and headers, thus creating a design constraint for the structural engineer that must be addressed. Air-sealed electrical boxes are another example of how different the air barrier, air sealing, and insulation installation table is from the base 2021 IECC that BuildSmart is amended from. It is now much more clear that a common electrical box needs to be airtight, but also that the electrical box, fan housing, or other enclosures have to be sealed to the building thermal envelope surface that they are penetrating. HVAC boots, on the other hand, have to be sealed to the subfloor, wall covering, or ceiling penetrated by the boot. In other words, they have to be sealed to all surfaces, not just when penetrating the building thermal envelope. BuildSmart makes it clear that a common electrical box or fan housing that has many holes in it can be made airtight, or an airtight box can be used, as called out in section N1102.4.6. Lastly, there is no guidance regarding insulation installation in the 2021 IECC, but in BuildSmart there is. So again, please ensure that the design and construction team reviews the requirements of this table. On the design side, the majority of the air sealing details that are required to be on the construction documents come from this table. Remember, examples of the required details on construction documents can be found on the Colorado Energy Office's website. Blower door testing is required by the BuildSmart code. Generally, this test will be performed by a certified energy rater. They will install an airtight fabric and frame into the building thermal envelope boundary between conditioned space and unconditioned space. A calibrated fan is used to depressurize the house to a known reference pressure of 50 pascals of pressure inside the home with reference to outside the home. If the home is leaky, a lot of air will go through the fan, and any air that leaves the house will be replaced by air coming in through holes in the building thermal envelope. If the house is tight, like is shown in the bottom picture on the right, then less air leaves the home and more air comes back in. When the energy rater has calculated the volume of the house and uses the testing software to conduct the test, they can calculate the cubic feet of air per minute leaving the house and the air changes per hour of air leakage that is happening in that specific house. The energy rater must perform the blower door test in accordance with a specific ANSI standard that is called out in the testing section of the BuildSmart code. I'm not sure why, but I've gotten several questions recently about if a heated garage should be included in the air leakage test. Boulder County has done a good job to ensure that there is no misunderstanding. This was already addressed a bit in the specific insulation requirements section N1106.2.1, but this section of code says that regardless of if the garage is heated or not, it is always outside the building thermal envelope and will never be included as part of the air leakage test. This is primarily because of the health and safety concerns associated with house-to-garage connection and all the pollutants that we tend to store in the garage, including the car itself. The maximum air leakage rate for any building or dwelling unit cannot exceed 3 air changes per hour for single-family buildings. For dwelling units in multifamily buildings or buildings other than single-family buildings, the maximum air leakage rate cannot exceed 0.20 cubic feet per minute per square foot of dwelling unit enclosure area, a different metric. This means that buildings that are not considered single-family residential buildings use an alternative air leakage metric that depends on the size of the building and could be leakier than 3 air changes per hour. The code allows an exception for attached single-family dwelling units, like townhouses, for example, where the common wall between units can cause elevated air leakage, and for buildings or dwelling units that are 1,000 square feet or smaller, where the unit's small volume makes it more difficult to achieve the volumetric leakage metric of 3 air changes per hour. The use of an air leakage rate not exceeding 0.25 cubic feet per minute per square foot of dwelling unit enclosure area is what the exception allows. This flexibility better ensures achievability of airtight building performance. Remember, however, that newly constructed buildings now also have to achieve compliance with at least the requirements of the Energy Star program, so programmatic compliance may drive the air leakage rate down below these maximum allowable leakage rates of the BuildSmart program. Be sure to reference back to the HERS Energy Rating Index energy model to determine what the leakage rate requirement is for any specific project. I just bring this section of code up as it is an example that is still required even though it is not specifically listed on the N1106.2.1 mandatory requirements table when or if atmospherically vented appliances are installed that require bringing in combustion air. In essence, you will have to build an airtight and insulated room around the mechanical room that ensures that the building thermal envelope defines the atmospherically vented appliance that brings in combustion air is outside of the building thermal envelope. This will ensure that outdoor combustion air that is needed for the atmospherically vented appliance does not interact with the conditioned air inside the building thermal envelope. In reality, this is a very difficult detail to comply with, so it is better to ensure that if you are installing gas-fired mechanical equipment, that you always install sealed combustion equipment. Moving on to mechanical system requirements in the BuildSmart code. The mechanical system requirements listed on this slide are largely embedded within what would be Section R403 of the 2021 IECC or Section N1103 of the IRC. I will be concentrating on the duct portion of this section, so I highly recommend that the design and construction team review the remainder of this section thoroughly before designing and construction begins. First off, the duct section of the BuildSmart code states specifically that the air handler of a ducted HVAC system must be installed within the conditioned space of the building or dwelling unit. Boulder County is beginning the process of bringing all the ductwork into conditioned space in a systematic and deliberate way by starting with the air handling unit. This is not a requirement of the base IECC and therefore needs to be addressed early in the design and construction process. Supply and return ductwork located outside conditioned space shall be insulated to an R value of not less than R8 and shall comply with sections N1106.2.1. Ductwork shall not be buried beneath a building or underground at all. So although the air handling unit cannot be installed in an attic, the duct can still be located in the attic if it is insulated to at least an R8. Remember that you can get a significant bump in the performance of your home as modeled using the HERS Energy Rating Index system if all the ductwork is located within the building thermal envelope, even though this is not a mandatory requirement. In addition, the energy modeling reality when complying with the HERS Energy Rating Index compliance alternative is that more insulation on ductworks located outside the building thermal envelope will increase the performance of the system and lower the HERS Energy Rating Index score. So if ducts are deeply buried in insulation in accordance with the code, they are allowed to be modeled as if they were insulated to an R25. However, this installation is difficult and expensive to achieve, and I will speak to that in a moment. This is what burying ductwork in insulation in accordance with the code actually means. So take some time now to read this slide and then start up the presentation again. As I said before, burying the duct in insulation is not an easy thing to achieve. Installation matters. In the picture to the left, you see that the trunk line was installed on the bottom core of the truss and that the takeoffs could have been located lower so that the supply ducts could be buried in insulation. I have seen successful systems that use spray foam to spray up and over the duct from the conditioned space ceiling to the conditioned space ceiling. In most cases, blown insulation is installed over the duct. The issue with this install is that you need enough insulation to have a smooth surface over the duct because if it is mounted over the duct, over time gravity will happen and the insulation will slide down and reveal the duct to the unconditioned space of the attic. There are a number of ways to bring the ductwork into the conditioned space that may involve creating some design constraints for your team. For example, the images on the slide show a truss design that recesses the duct up into the ceiling after a drywall or OSB air barrier has been installed. The thermal envelope of the building is directed up and around the built-in duct chase. Continuity of the building thermal envelope is still required in this application, which may mean that the vertical side of the built-in duct chase would need to be considered a knee wall and constructed to insulate in that manner. Otherwise, blowing insulation up and over the ceiling height transition may work if you can get enough insulation at the transition points to maintain the code required R value. You see, this takes some design thought and maybe some constraints or boundaries put on the design team to figure out early in the design process. Because of our desire to have open floor plans and other geometry in our homes, at times there is no good choice for where to locate the duct. The code describes what it means to install the duct within conditioned space in some of these locations. First, the obvious choice is to just install the duct within the conditioned and continuous air barrier and within the building thermal envelope. We have talked a bit about ducts in vented attics. If installed as described on the slide, the duct can be modeled as if it has been installed within the building thermal envelope because it will essentially perform as if it is. There are also ways to make the duct that are installed within an exterior insulated building assembly that is defining the building thermal envelope to perform as if they are inside the building envelope. Ductwork located in floors over garages or in cantilevers, or ductwork installed in insulated walls that are used to get duct from the basement to the second floor, for example. Regardless of this allowance in the code and the benefits to the HERS Energy Rating Index score modeling, it is still not the most recommended way to install ductwork. Best practices for performance would be to clearly bring it into the conditioned space of the house. The reality is that all joints, seams, gourds, connections, and all holes in a duct system are required to be sealed. All ductwork, including ventilation, dryer, and kitchen hood duct, is required to be sealed per the IRC. Liberally applied mastic is your best tool to use to make the duct airtight. Flex duct primarily leaks at the connection points, and there are several resources for best practices for installing flex duct that should be considered that go beyond the air sealing. At the levels of tightness required by the code, the manufactured joints will leak as well, so make sure that they are sealed and sealed well. This includes gourds or at elbows and seams at duct boots. In addition, the air handler is required to be tested by the manufacturer not to leak more than 2% of the designed flow. That could be enough leakage to fail a duct test, so don't be afraid to air seal the cabinet itself. Filter slots are required to be airtight and cannot be taped off during a duct test. And don't forget that air sealing the duct and the system as a whole while it's being built is the best practice. All HVAC duct systems are required to be tested regardless of where they are located. You may test at a rough stage of construction, which often makes the most sense, as if there is leakage, you can fix it prior to drywall. Or you're allowed to test at a final stage of construction, whichever works best for you. Regardless, for the BuildSmart code, using the HERS Energy Rating Index compliance alternative, you will have a duct leakage outside test at final in order to produce the final confirmed energy, modeling, and compliance reports. Whole house controlled mechanical ventilation duct does have to be air sealed, but there is no requirement to test that duct unless the duct is integrated with the duct servicing the system that is heating and cooling the house itself. The compliance metric that is used to demonstrate compliance with the BuildSmart code depends on when the system is tested and if the system is servicing more than 1,200 square feet. If you test at a rough stage of construction, the system can't leak more than 4 CFM per 100 square feet of conditioned floor area served by the system itself. For a 2,000 square foot home, for example, the system can't leak more than 80 CFM of air. If the system is tested at a rough stage of construction and the air handler is not installed yet, but both the return and the supply side of the system must be tested, and together they can't leak more than 3 CFM per 100 square feet of conditioned floor area served. For a 2,000 square foot house, for example, the system cannot leak more than 60 CFM of air in this case. If the system is being tested post-construction, the 4 CFM target is used, and if the home being tested is 1,200 square feet or less, you can use the exception that is stated on this slide. Lastly, the duct leakage to outside test used in the energy modeling software for the HERS Energy Rating Index compliance approach also uses the 4 CFM compliance target. The picture on this slide shows the potential impact of using building cavities as pressurized ductwork. In this ranch-style house, the return is pulling from the room as well as the attic on this hot summer day, thus making the HVAC system work harder and making it much more difficult to cool the house. Now, there is some conflict between the IRC and the Energy Code on this subject, but the applicability section of the code ensures that the requirement to not use building cavities as pressurized duct systems stands in Boulder County. BuildSmart does not only require balanced whole house controlled mechanical ventilation, but they also require using either an energy recovery ventilator or a heat recovery ventilator system. In addition, the ventilation system must have a minimum sensible heat recovery efficiency of 65% at 32 degrees and a fan efficacy of 1.2 CFM per watt or be Energy Star compliant. Balancing of the mechanical ventilation system is required and its flow rate must be determined by ASHRAE Standard 62.2-2013. As we just saw, testing and balancing of whole house controlled mechanical ventilation systems is required. Because mechanical ventilation must comply with section N1106.2.1, all ventilation systems, including spot ventilation systems in kitchens, laundries, and bathrooms, must be tested and verified. This is because N1106.2.1 points you to IRC section M1505 that gives the minimum flow rates required for fans located in kitchens, laundries, and bathrooms. Proper HVAC design is also required by the BuildSmart code. A manual J, S, and D report are required to be turned in for review for permitting of the house. Remember that if specifications change during the construction of the house, these calculations also may need to be updated. The three major steps of HVAC design are first calculating the heating and cooling loads, then selecting the equipment with a capacity that can meet the load, and finally designing a duct system that can distribute and condition air from the equipment to the rooms and then back again. Following these three steps is key to maintaining an efficient, comfortable, and code-compliant home. In addition, as we see more and more cold climate heat pumps being specified, the design process becomes even more important, which means that, again, making decisions and having discussions early on in the design process becomes more and more important. Lastly, for existing buildings using the prescriptive compliance alternative, please review the minimum equipment efficiency values that are detailed out in Table N1103.9.1. There are several sections in the N1103 Systems section of the BuildSmart code that I have not touched on, including systems controls, hot water heaters, pipe insulation and protection, hot water circulation systems, drain waste heat recovery, and more. Please be sure that the design and construction team reviews these sections thoroughly. Our last section of mandatory items is the electrical power and lighting system requirements that are listed on this slide. They are within what we would call Section R404 of the 2021 IECC or Section N1104 of the IRC. Where in the past only a percentage of the lighting in a house had to be efficient, now all installed lighting is required to be high efficacy lighting. In reality, this means LED lamps should be installed everywhere except in appliance lighting applications. We covered additional electrical infrastructure in the new home compliance presentation, but again, BuildSmart does not prohibit the use of fossil fuel mechanical equipment. It does require, however, that additional electrical infrastructure be added next to any installed fossil fuel appliance, such as the furnace, hot water heater, and cooktop. This includes properly labeled reserve space in the electrical panel for the properly sized breakers that can serve the future equipment. This future proof of the home allows the consumer more choice when the mechanical appliance fails or needs to be replaced. We also covered the adopted EV-ready space requirements in the new home compliance presentation. But again, an EV-ready space means that the electrical infrastructure has been run to the designated space, and that the electrical panel, electrical distribution equipment directory, and all outlets or enclosures are marked for future electrical vehicle supply equipment. Also remember that the space should be located on the construction documents. Well, that is the last of the mandatory requirements for Table N1106.2.1. Remember that the table is designed to centrally place all the requirements that are embedded within the IECC, or now the BuildSmart code, to better clarify that in addition to determining how the home will achieve compliance with the HERS Energy Rating Index score, the home also complies with these other requirements that are embedded within the code that we just reviewed. We have reviewed the highlights of this requirement section, so please be sure that the design and construction team reviews these amendments in their entirety and as they are listed within the code itself. To round things out and finish our review of the Boulder County BuildSmart code, let's talk about who will be inspecting and verifying these homes for compliance with the requirements that we have been talking about. Within BuildSmart, Boulder County has adopted the 2024 IECC update to the approved third-party inspection agency. Boulder County is authorizing accredited ResNet HERS energy raters to be inspection agencies for energy code compliance. Being a rater in good standing with ResNet and the rater's HERS provider is what the county is currently relying on to demonstrate qualifications and reliability for conducting inspections. The county is reserving the right to request information at any time regarding qualifications. And more importantly, the county also reserves the right to disqualify any energy rater, energy rating company, or energy rating provider from working in Boulder County to perform Boulder County BuildSmart code compliance, inspections, or energy modeling. Energy rater approved third parties must maintain their independence as a separate business identity from the builder, architect, or trade partner that they work with. The scope of the energy rater role are spelled out in the BuildSmart code to develop code-compliant energy models and reports documenting that the home meets the HERS Energy Rating Index requirements for permitting and to receive the certificate of occupancy. To inspect that the home has met the requirements as detailed out in the BuildSmart code, not just the minimum rated features needed to create the HERS Energy Rating Index. For example, the BuildSmart code requires that all insulation be installed in accordance with the ResNet Grade 1 standard, even if the energy model can demonstrate compliance with the HERS Energy Rating Index using a Grade 3 installation. The code requirements, like programmatic requirements, say Energy Star, for example, are what the rating must reflect. The county understands that the energy rater has an implied conflict of interest because their fee comes from the builder, architect, or homeowner paying for the project. The county therefore, again, reserves the right to remove or suspend the ability of the rater from being able to perform code compliance work in the county for any reason, be it perceived or actual. The approved energy rater must provide all necessary equipment needed to perform thorough inspections to the requirements of the BuildSmart code. All equipment that requires periodic calibration must be properly calibrated. The county reserves the right to request without notice calibration documentation. It's the responsibility of all third-party ResNet HERS energy raters to be thoroughly familiar with the BuildSmart code. Large energy rating companies will only send raters who have been properly trained to inspect homes for compliance with the BuildSmart code. Boulder County implicitly delegates authority to third-party ResNet HERS raters to determine compliance or noncompliance to fail inspections and to re-inspect failures for compliance as dictated by the findings of their inspections. Approved third-party ResNet HERS raters must keep records of all work performed within the county. Inspection and compliance reports must be submitted to the building department regarding permitting and to receive the certificate of occupancy and for each inspection that is performed on site. The reports must indicate compliance, noncompliance, if the inspection is for a reinspection for noncompliance, and if the issue has been satisfactorily addressed to pass the requirements of the BuildSmart code. If it is not clear what reporting is required for permitting, field inspection, verification, and compliance, and final compliance, as well as what is required to be inspected for in the field, the approved third-party ResNet HERS rater is responsible for scheduling a meeting with the building department to gain any necessary clarification. So, to conclude, code compliance means compliance with the requirements we reviewed as laid out in the BuildSmart code, as well as achieving the required HERS Energy Rating Index score. Compliance also may require certification using a building program such as Energy Star, depending on the size of the house. Please consider watching our presentation on programmatic building to clarify what that means. Remember that we did not review each and every requirement that is within the BuildSmart code, so please take some time and read through the code itself. Lastly, building is a team sport. Get your project team together early and before you start design. Early and frequent energy modeling will be needed to help guide the project through. If specifications or other things change during construction, you will need to go back to the energy model to ensure compliance can still be achieved. Thank you for listening to this presentation on BuildSmart compliance with the mandatory sections of the code. You can download the Boulder County Building Code and amendments that include the BuildSmart code from the web address on this page, or just Google Boulder County Building Code. On the right side, Related Links section, you will see a direct link to the BuildSmart code. If you have questions, please reach out through email or by phone. Please look at the Boulder County website for other presentations on how to comply with the BuildSmart code. Thanks much for listening to this presentation.